Generative AI is changing the world in ways we never imagined. It's the tech behind those AI image generators everyone loves. Think DALL-E or Midjourney, which can create stunning visuals from simple text prompts. You type in what you want to see and boom, the AI creates a picture that can be as realistic or as fantastical as you desire. But it's not just pictures. Generative AI is capable of so much more. Generative AI can write stories, compose music, and even create entire virtual worlds. It can also design new drugs, revolutionizing the pharmaceutical industry. It's pretty wild stuff. This technology is rapidly evolving with advancements happening at an unprecedented pace. New applications are popping up all the time, each more innovative than the last. It's being used in healthcare to diagnose diseases, in finance to predict market trends, in entertainment to create immersive experiences, and more. The possibilities seem endless, but there's a catch. All this amazing AI needs a ton of power to run, and that's a significant challenge. And that's where things get complicated. The infrastructure to support this power demand is under immense pressure. The more we use generative AI, the more energy it demands, leading to increased consumption. This surge in demand is putting a strain on our existing power grids, which are already struggling to keep up. We're talking about a potential energy crisis if we don't find a solution. Renewable energy sources and more efficient technologies are crucial to sustaining this AI revolution. Data centers are the backbone of generative AI, the silent workhorses that power the digital age. These massive warehouses are packed with rows upon rows of servers, each one tirelessly working to process data. Think of them as the brains behind all the AI magic, constantly calculating and learning. These servers store and process the vast amounts of data that AI models need to function, ensuring that every query and command is met with precision. Training a single AI model can consume as much electricity as a small town, highlighting the immense power requirements.
And we're not talking about just one model. The scale is much larger. Thousands of models are being trained and used every day, each one demanding significant computational resources. The energy consumption is staggering, with data centers drawing power equivalent to small cities. Data centers need a constant supply of power, without which the entire system could fail. Any interruption can lead to data loss or downtime, which can cost companies millions of dollars in lost revenue and productivity. As the demand for AI grows, so too does the need for more data centers, leading to a continuous cycle of expansion. And that means more energy consumption, pushing the limits of our current power infrastructure.
Data centers are energy hogs. They require enormous amounts of electricity to power their servers and keep them cool. In fact, data centers account for a significant portion of global electricity consumption. And as AI becomes more prevalent, this energy demand is only going to increase. It's like trying to quench the thirst of 1,000 suns. The energy needed to power these data centers is mind-boggling. We're talking about gigawatts of power, enough to power entire cities.
This energy consumption has a direct impact on our environment. Most of the world's electricity still comes from fossil fuels. So as we build more data centers, we're essentially burning more coal and oil to power them. This releases harmful greenhouse gases into the atmosphere, contributing to climate change.
The power grid is already under stress. Aging infrastructure, increased demand, and extreme weather events are all putting a strain on our ability to generate and distribute electricity. And now, we're adding the energy demands of generative AI to the mix. Imagine a traffic jam, but instead of cars, it's electricity trying to get to where it's needed. That's what's happening to our power grid.
The increased demand from data centers is causing congestion and instability. This strain on the grid can lead to brownouts or even blackouts. That means businesses could be forced to shut down, hospitals could lose power, and people could be left in the dark. The consequences are far-reaching and potentially devastating. Blackouts are a real possibility if we don't address the energy demands of generative AI. As our reliance on technology grows, so does our need for electricity. Generative AI, in particular, requires immense computational power, which translates to higher energy consumption. When the demand for electricity exceeds the supply, the grid can become overloaded and fail. This is not just a theoretical concern. It's a very real risk that we face as our energy consumption continues to rise.
This can lead to widespread power outages, disrupting our daily lives and causing economic damage. businesses could lose millions, and essential services could be interrupted. Imagine a world without internet, no smartphones, no lights. Our modern society is heavily dependent on electricity, and a major blackout would bring everything to a standstill. That's what a major blackout could look like. The impact would be felt across all sectors, from healthcare to transportation to communication.
Hospitals wouldn't be able to function, transportation systems would grind to a halt, and our entire way of life would be thrown into chaos. Emergency services would be overwhelmed, and the safety of millions could be at risk.
And it's not just a hypothetical scenario. The increasing energy demands of data centers are already putting a strain on our power grids. We've already seen instances where data centers have caused power outages. These facilities require a constant and substantial supply of electricity to function. In 2011, a heat wave in Arizona led to a massive power outage that was partly attributed to the energy demands of data centers in the state. As climate change continues to cause extreme weather events, the risk of such incidents will only increase.
Data centers are not just energy hogs, they're also major polluters. The vast majority of data centers are powered by fossil fuels, which release harmful greenhouse gases into the atmosphere.
These emissions contribute to climate change, leading to more extreme weather events, rising sea levels, and other environmental problems. It's like we're building a digital world at the expense of the real one.
The carbon footprint of data centers is growing at an alarming rate, and we need to find a way to reduce it before it's too late. The environmental impact of data centers is a serious concern.
We need to find ways to power these facilities with clean, renewable energy sources to mitigate their impact on the planet. The future of AI depends on it.
Renewable energy is a key part of the solution to AI's energy problem. Solar, wind, hydro, and geothermal energy can all be used to power data centers without relying on fossil fuels.
By transitioning to renewable energy sources, we can reduce the carbon footprint of AI and create a more sustainable future. Imagine a world where data centers are powered by the sun or the wind. It's not a pipe dream, it's a very real possibility.
Companies like Google and Facebook are already investing heavily in renewable energy to power their data centers. The transition to renewable energy won't be easy or cheap, but it's essential if we want to continue to enjoy the benefits of AI without destroying the planet in the process.
Section 8. Cooling down data centers. Innovations in cooling technology. Data centers generate a lot of heat. All those servers working overtime produce a tremendous amount of thermal energy that needs to be dissipated to prevent overheating.
Traditional cooling methods, like air conditioning, are energy-intensive and contribute to the overall carbon footprint of data centers. It's like trying to cool down a furnace with a fan. Traditional cooling methods are simply not efficient enough to keep up with the heat generated by modern data centers.
But there's good news. Innovative cooling technologies are emerging that can significantly reduce the energy consumption of data centers. Liquid cooling, for example, uses liquids instead of air to dissipate heat, which is much more efficient. Section 9. Sustainable AI, the need for responsible AI development. As AI continues to advance, it's crucial that we develop it responsibly. That means considering the environmental impact of AI from the outset and designing systems that are energy efficient and sustainable.
It's not enough to simply create powerful AI models. We need to ensure that those models are developed and deployed in a way that minimizes their environmental impact.
Sustainable AI is about more than just reducing energy consumption. It's about developing AI systems that are fair, unbiased, and beneficial to society as a whole. Section 10. The future of AI and energy balancing innovation with sustainability. The future of AI is inextricably linked to the future of energy. As AI continues to evolve, so too will its energy demands.
We need to find a way to balance the incredible potential of AI with the need to create a sustainable future. It's a delicate balancing act. We can't afford to stifle innovation, but we also can't ignore the environmental consequences of our actions.
The good news is that there are solutions available. By investing in renewable energy, developing more efficient cooling technologies, and promoting responsible AI development, we can create a future where AI and sustainability go hand in hand. Section 11. Our shared responsibility, a call to action. The energy challenges posed by generative AI are significant, but they're not insurmountable. It's a shared responsibility that requires collaboration between governments, businesses, researchers, and individuals.
We all have a role to play in shaping a future where AI benefits humanity without compromising the health of our planet. This is not someone else's problem to solve. It's on all of us to demand sustainable practices from the companies developing and deploying AI.
We need to advocate for policies that promote renewable energy and energy efficiency. The future is in our hands. Let's work together to create a world where AI is a force for good, both for humanity and for the environment.